Hello, everyone. My internet connection's been stupid again. So, well, not anymore, but it was. Can't say I understand what's going on. You gotta develop your internet connection from scratch. Don't threaten me with a good time. I might just. Yeah. Not sure what's going on with my internet, but I ran a speed test on both this computer and my laptop, and it's vastly different between the two. There's a chance that's because I'm streaming from this computer, but like, why would that affect my download speed? Make it half of what it actually is? I have no idea. But yeah, maybe something is happening with this computer. I don't fucking know. Maybe something to look into. But the second I started streaming, like when I was actually gonna start the stream, it immediately dropped to 0. And I restarted my router. That took literally like 6 minutes to actually like restart the router to the point that my internet was usable again. And now it works. So God knows what's going on. Anyway, overcomplicated protocols magic is right. Maybe I should just create my own internet at this point. Like, screw this. Why am I gonna bother with this kind of shit? Okay, what was I going to say? Stream Elements bot is running. Good. Good. Stream started 6 minutes ago, so I'm happy that that's running. Yeah. It seems to be working fine now. I have no idea what's going on. Although it is raining cats and dogs out there, and there's a leak. Yeah, I literally just said that so I can make that joke. Very funny, as you can tell. I actually used to be a comedian, but I can't say anything in this political climate anymore, so I stopped. And now I'm a programmer. I wished who developed Ghidra a good day in hell 30 minutes for a font change. Well, good news! They got your message. Because the NSA created Ghidra. So they got it. Thank you. Actually, the only reason the NSA is like spying on you or whatever, like Edward Snowden said, that drama queen, is just so they can get feedback on Ghidra. It's just analytics. It's just analytics on their product. That's it. Was Ghidra even a thing when Edward Snowden did that? I have no idea. Probably not. $2019. Okay, so it wasn't. Hey, Crumbus. Thank you for the subscription. Ghidra was not around in 2019, so they were actually doing market research. All right, I'm changing my story. The reason the NSA is spying on you is that they were just doing market research for Ghidra. Where someone spelled wrong G Hydra and they were pretty salty. Could be. Okay, in yesterday's stream, I was talking about the MMU, and I was talking about having some issues with it, with virtual addressing. I talked about, there's a problem with the way that I'm doing it, and it wasn't working, and now it's working. It is macOS, yes. I'm sorry to say you just subscribed to somebody who's working from macOS. unfortunately. In case you want to take it back. That's just the system that I developed from. It is also genuinely better than Linux. I am sticking to it. It is the spiritual successor to Unix. Despite me putting out a video about 20 minutes ago complaining about Unix, how long ago was it? 23 minutes ago, complaining about Unix. It is the successor to Unix. And it's a pretty nice system to use. At least it's not Windows. Yeah, definitely. I hate Windows too. Genuinely, it's Mac OS, Linux, Windows. Actually, Windows is like way below, like basement level. But the camera is not wireless and it only goes so far, so I can't go all the way to the basement, the non-existent basement of my building, just to prove a point. So you'll have to take my word for it. Also, it's I forgot, Mac OS, Linux, redacted, Mac OS, Linux, redacted, Windows. I like Linux, but for work I kind of want a MacBook. Yes. Mac is Linux as a commercial product, essentially. Easy to use. They've done market research. The battery is pretty good, I have to say. They're super durable. You can still use a Mac from like... Shit, I still have a Mac from 2017. They last a long time. I'm not even talking about the battery, which, yeah, eventually, like a nearly 10-year-old computer, the battery literally doesn't even work anymore. But the damn thing works. That's pretty cool. It's user-friendly it's user-friendly Linux. It's what the people that say year of the Linux desktop wish Linux was. What's this button? Huh? Wait, what? Bro, what? You can do this? My Winshit laptop's battery is absolutely fucked. I'll give you one thing. It's easier to replace a battery on a Windows computer. Thanks, Asus, for not replacing broken batteries. I'm taking it right back. Forget what I said. Apple will replace your battery. It's just harder for you to do it. And I guess like a shop will do it for you as well. It's just like you're not supposed to do it. 40% max capacity in the first 6 months? Jesus Christ. Like the iPhone doesn't have great battery capacity. It has decent battery capacity. But the MacBook has really good battery capacity. And they're also like really powerful computers. Really durable. Really everything. Removable batteries. Like the ones on normal laptops, you mean? Or I'm not sure what you're talking about. Or like power banks. Not sure. Clearly I haven't heard of them. Legends say that you were in charge of your PC once upon a time. Yeah. Yeah, it's not easy to repair a MacBook, but it needs a lot less repair. I'll give them that much. And no, we are talking about laptops. I just didn't know what you meant by removable battery, but yeah. It used to be simpler. I honestly don't know and don't want to know what a Windows laptop is like nowadays. Like if I go to a store and pick up a random laptop, that isn't a ThinkPad. I don't know what that laptop is gonna look like nowadays. Actually, I wonder. I'm just gonna Google laptops. Go to the first website I find, which is gonna be in Spanish, but whatever. Just want to see what it looks like. It's Black Weeks. Not Black Friday anymore. It's Black Weeks. Cool. Oh god, there's laptops with AI. Holy shit, let's go. Alright, I gotta see one of these. Black Year coming soon. And the worst part is they don't even do actual discounts. Framework making everything easy is their whole business plan. Yeah, but that's why I'm not saying like, okay, like a specific brand. I'm just saying like the average computer. Like, okay, the first one I find, literally. Although this is with AI. Just want to see like what it looks like. I can't say it. It looks like a like an off-brand MacBook. Yeah, AI is a strong word. AI tag on the bottom left. Hold on. Mind you, I literally clicked on laptops with AI. No, can I like translate the page? From Latin? Alright, it worked. An AI to determine file types? Holy shit, almost as if file types were made to be determined easily. Yeah, so this is like straight up not working. Whatever. I guess we'll have to look at this in Spanish. Sucks to be you, not Spanish people. What? I didn't choose to be born Latina, nomás tuve suerte. AI keyboard is coming. What would you need to type for? Just let the AI do everything. All right, I want to know what this... Okay, no, you know what? Let me not look at AI laptops. Let me look at an average laptop and see like what it looks like. It's listening 24/7. Exactly. You don't need a... you don't need a... Is that still the same result? It looks exactly the same. Although I'm not seeing the words AI anywhere. The second... Okay. So you look up laptops and you got this one, and then immediately you got a MacBook. So that's kind of, and then you got a fucking Lenovo IdeaPad, which is like what, the ThinkPad, but like change it enough so they don't notice that we're releasing the same product with a different name. I just want to see what the average laptop looks like. And I said, I don't want to look at a MacBook and I don't want to look at a ThinkPad. And then immediately the first two that come up. Okay, this one looks like it could be somewhat easy to like open up and change. Although it is still Lenovo, so I feel like... Okay, show me something that's not fucking Lenovo. This is the same one as before. There's 3 computers. There's 3 computers for sale in Spain right now. That's all we got. What happened to laptops being 6 inches thick? They should be. You know, people like their laptops portable. And if they need to have their batteries replaced, they do it at a store. You know, once every like 3 years. What's FreeDOS? It's not available. Okay. It's 579. You're literally paying $100 for the privilege of using Windows. So is FreeDOS like an actual thing? I had never heard of it. Open source DOS compatible operating system. Seriously? Alright, I thought it would come with Linux. Okay. I mean, I had heard of it. I just didn't like recognize its name. Interesting. And you get to not pay $100 for Windows. Sucks, kind of, but hey. It's DOS, but open source. That's pretty cool. So it doesn't look like there's a whole lot of choice. And it doesn't look like a lot of these laptops are like super portable. Not portable, but like modifiable. So it's not even an Apple thing. I thought it was genuinely just an Apple thing. Granted, I can't look at the bottom of them because like why would they put that in the pictures of the product? But they don't look super easy to open up and change. Compaq SLT. Okay, the compact slot. Sorry, SLT. Oh. May not be a slot, but it's thick. Damn, look at that. Computer speaked right here. Alright. I don't know that this is what a laptop should look like. It's gonna be like... Alright, hold on. I need to get some work done. Hold on, let me just... Yeah, I feel like this is maybe not the best. There's some in between that we can reach a compromise. Framework laptops. Configure once, upgrade whenever. Can I get ARM on it? Because if I can, I'm buying one right now on stream. I don't care. No. I cannot even get like AMD. There is AMD? I'm not seeing it. I mean, I don't know AMD, so maybe this naming convention is also for AMD, but I don't think it is. It's other size. Oh, I'm sorry. When I went into the customize for the customizable laptop, I thought it would show me all the customization options. Okay, here's Ryzen. AI. AI. I love you, AI. Thank you. I can build my own AI computer. With a deposit of $100. And yeah, it was like, how much was it? Like almost 2,000? 17. Jesus Christ. A MacBook is cheaper than that. All right. So does each size come with a different like processor? No, all these are Ryzen. Okay. All right. So let me see the best one I can build. You have to assemble it yourself, and it's still more expensive. Jesus Christ. All right. Oh, there's a cheaper version. No, it just has a discount. It's $80 cheaper. Oh, here you pick the... Okay. All right. Let's go with Intel, because I know Intel at the very least. I don't really know AMD, so... Okay, I don't know what an Ultra is, to be honest. I know like i5, i7, I knew that. I'm not actually buying it, to be fair. I'm just like configuring one to see what it's like. All right, keep in mind there's discounts. I'm not sure if this is maybe like one of those discounts that's always there, and so it's not really a discount, but whatever. All right, 6 to 8 cores. With a 2.8 display. 13-inch display. We'll get, let's make it like somewhat comparable to my laptop. Although being a Mac, it's more expensive probably. Oh, we'll see how much more expensive it is. We'll make it 48. I think 1 terabyte. We're not using Windows. Although you're probably paying for the operating system in a Mac integrated into the... Is it lagging a little bit? No, it's not. Why are you buying a laptop on every stream you're in here? I'm not buying a laptop, I'm just checking them out. Alright, I can't make a MacBook orange, so we'll make this one orange. The keyboard, we're gonna make it US English. We'll have to get a power adapter, EU. I do travel a fair bit, but I have a laptop already. What do you mean additional ports? Say I want like 3 USB-C ports. Orange, green, and is there yellow? No, pink. One HDMI. One. I don't use it. Ethernet, yeah. My MacBook is missing Ethernet and I wish it did have it. An SD card. Oh wait, they have a micro SD card. That's pretty cool. Let's get one of those going and add it to the bag. It's like half the price of a MacBook, so not bad. Yeah, I don't think those were like dongles to like go between USB-C or anything. I think those were just like for the actual computer. Like you pick what ports you wanted to have. I guess, I'm not sure. Now, if this had ARM, I would genuinely consider buying one. Because I really want an ARM computer so I can develop redacted OS on it. Well, for it. It's gonna be a while before I can like have it self-hosted, but yeah. Alright. So, again, I don't know what an Ultra 7165 is. ARM would be neat for battery as well. I genuinely don't know why ARM is not more popular. For the love of God. There's like one ARM laptop out there and max. I forgot what it's called and who makes it, but yeah, there is one. It's got a 2.8K display. It's kind of shitty. It's got Wi-Fi. It's got 48 memory. It's got 1 terabyte. It comes with a screwdriver. Oh, thank God. No one wants Windows Copilot shit. Exactly. That part I can tell you. Nobody fucking wants that. Wait, come to think of it, I'm actually starting off on the wrong foot here. I should have checked the laptop 16 because my Mac is 16. So 12 core is already lower than mine. You can get... Damn, okay. You can get a 5070. Cool. This thing has more memory than my SSD has free space. You know the funniest thing? My laptop actually has 48 memory. And then with swap, you can get up to like 100. And Final Cut Pro that I use for editing had a memory leak. And so when I was trying to edit my like 10-hour video, it kept crashing. It's pretty funny that actually the system is still very, very usable when your RAM and swap are completely taken up. But yeah, that, to be fair, that's a issue with the software, although it's still made by Apple. And it's supposed to be like professional software used to make movies, so whatever. Then again, there's like a dedicated app for making, for like exporting the videos. And that one doesn't have a memory leak, so I ended up using that. But yeah. All right, 48. Wait, did I end up getting the... Yeah, no. If I want to get... Like comparing it to my laptop, I can't get that. 1 terabyte. Software is absurdly heavy. Yeah, it bothers me so fucking much. No secondary storage, no Windows. Although again, I said there's a chance that you're actually paying for macOS, like a base fee included in the computer's price, but I don't know. We need a power adapter. I use Linux, but I've been using X11. It looks terrible. Should I use Wayland? Honestly, I stay as far away from Linux as possible, but I think so. All right, we want a US English. We then want, again, 3 USB-C ports in orange, 1 HDMI, 1 SD card, 1 audio. The other one doesn't have an option for audio. I didn't even notice. I'm assuming it comes with the charging thingy already. Okay. It's like half the price of a MacBook still. But it's not great. Ships December. I'm definitely not getting it. Again, if it was ARM, I would definitely consider it. I saw someone suggesting System 76. At least it's not a System 67. Thank you for that one. Oh, they got laptops. The Lemur Pro. This is the Oryx Pro. Ship in early December. It's got machine learning and AI. Thank you. Well, processor speed doubles every 2 years. Software efficiency halves every 1.5 years. It genuinely feels like since I started getting into computing, because I don't want to say programming, but yeah, into computers, hardware has gotten so much better. Genuinely, the hardware that we have today would have blown my mind 10 years ago. And yet, in terms of software speed, it's about the same. Why do you want ARM? Because my system's made for ARM. And I think it's the future. Rush assembly, okay. No additional charger. Let's face it, they're not super cheap. Then again, what I'm having a hard time comparing is the processor. Because, yeah, the processor for the other one we saw, the framework one, was a little bit worse than that of a MacBook. Had like 12 instead of 16 cores. So is this one. No, wait. 16 threads. I have an M3 Max. Eight-core CPU. Okay, so it's actually better. No, wait. The Max has a 14 or 16-core CPU. Never mind. It's slightly better, but not that much. Though the price is much better. Then again, the quality is not as good. Threads are not a CPU spec. They are, to a certain extent. Physical threads are. Are there actually like ARM laptops? Wait, the IdeaPad? No, why are you... This is not what I was looking for. The MacBook Air, the VivoBook, the Snapdragon chip. Thank you. Why do they vary the number of cores for the M3 Max? It depends on the actual laptop that you get. I think you can upgrade it as well, And 13 and 16-bit computers have like different computers, different cores. It's $500. All right, somebody subscribed earlier, so clearly I am able to afford it. It's about the same price times 1,000, but whatever. Well, times 100. So yeah, I just need 100 people to subscribe real quick. We're not even close to 100 people watching, but yeah. I just need you to do that so you can invest in my buying a $549 laptop and then developing Redacted OS for it. Yeah, there are some Lenovo's with it. I can barely get it to work on a Raspberry Pi, so yeah. Maybe I should hold off on that one. Snapdragon Elite might power future Android PCs. I understand it's 9 to 5 Google, so they really need to make it about Android somehow, but oh, please don't. Land a Fang job and then I will donate for sure. Oh, don't do that. The Fang job, I mean. If you feel free to donate, but don't do that to yourself. Cannot imagine it's a pleasant experience. Wait, the Surface also uses it? Oh my god, the best computer. Actually, I wonder, how much is a Surface? Hermano, why is it in Spanish? Threads where processor CPUs could run in parallel. I mean, yes, those are like virtual threads, but then there's physical. They fired 100 programmers right now. Yeah, they're firing people left and right for AI. And then finding that AI can actually not replace those people. All right, let's see the Surface Pro. Wait, they sell Surface laptops? These people were like, hey, we make like really, really shitty software. You know what we should do? Make hardware. All right, here it is. Tell me the price. How much is this gonna hurt? Like I'm gonna buy this. Oh, it can run Discord? Okay, that changes everything. I can build my perfect setup. All right. Oh, here it is. Okay, 799. Oh, it's cheap for a glorified tablet. And glorified is a strong word considering it's glorified by Windows. Need I say more? Good luck running ARM Windows. I've heard good things about it, but then again, it's Windows, so... I mean, if I were to get ARM, I would not be interested in getting Windows. I want to make my own system, run on it. But then again, I would never buy Windows hardware. I mean, Microsoft hardware. I would never do that to myself. That would be ill-advised, to say the least. Wait, Dell also makes ARM laptops? Physical threads. Yeah, physical threads and virtual threads are different. There's a limited number of physical threads, but then you can make different virtual threads that map to the limited number of physical threads. And then you can have as many as you want. We noticed that ads aren't being displayed, boo-hoo. $1,000 at Amazon for the Surface Laptop 7. So it's even more expensive than it was before? What the hell happened? Oh, because this is a laptop. That was a tablet. They're not cheap. They're low-key kind of expensive. Alright, so we're not quite there yet for ARM laptops. I have enough time to like finish my operating system, make it like somewhat stable, and then by the time the ARM laptops really take over the system, the market, my system's gonna be there to power them. This is a long-term investment, all right? We're talking a few years. Okay. Enough talking about laptops. We're gonna talk about operating systems. I actually have no idea what we're gonna do today. Did I say yesterday what I could work on today? I feel like I did, but I don't remember. Redacted OS full release before GTA 6. It's a possibility. It's a possibility. ARM will never take over? I don't know about that. I don't know about that. It's already taken over. Actually, Apple switching over to ARM is huge. It's already a pretty big deal. And it will take over eventually. It's gonna be the year of the ARM desktop before it becomes the year of the Linux desktop. I can tell you that much. Okay. So, my system can run multiple apps again. Yesterday I was having a bug with that. Today it's fixed. I officially have virtual. I haven't tested it on this computer, so I probably should. I will never let Steve Jobs take over the processor market. Well, he's a little bit dead. Yes, it runs multiple apps. And another thing I wasn't able to test is this. Is the flickering new? Yeah, the flickering is new. Didn't used to happen. Yeah. Everything's running a little bit slower. There's still some improvements to be made, but we're running 2 different apps in virtual memory, so they're both using the same addresses. Which yesterday wasn't working, so officially, I can say I still have to make some improvements, like I said. But where is it here? My homework is done. We're gonna put it. We're gonna leave it out here because it's not full. Well, we have full virtual addresses, but I still need to make improvements, like I said. The MMU gets initialized after the peripherals, after pretty much the entire system is booted, and that's like not really secure. So it's literally just a matter of here's my plan for it. I'm gonna do it off stream. I'm not gonna do it today, but the plan is this MMU in it, which actually initializes the virtual memory and all that, used to be here. So after all the peripherals. I was able to move it back before the audio gets initialized, before the network gets initialized, and it works. If I move it to before the input is initialized, it crashes. So I'll need to figure out why it's crashing. There you have it. I'll need to figure out why it's crashing and then fix that. It's probably something that I'm not mapping that I should. So it's just a matter of figuring out what it is. Then the solution is super simple. Just map that thing and that's it. And then continue doing the same thing. Move it back until here, which is where it's actually supposed to be. Actually, I wonder what happens. Where does it crash? It doesn't even work. Yeah, so that's the next task when it comes to the MMU. At which point, I'm going to also consider how I can use virtual addresses to my advantage. How I can, mess around with them a little bit and um, like do stuff with them. Yeah. So that is my plan for virtual addressing. For example, one thing that I was considering immediately, like when it came to virtual addressing, is the ECS architecture in my game engine. Could really take advantage of that, because the good thing about ECS is that you process things that are continuous in memory in a sequential manner. And with virtual addressing, we can make things that aren't continuous in memory look like they're continuous in memory. And then you can take advantage of that. So I want to see how much control I can give the individual app over their own virtual memory. And how I can maybe like structure the system, standardize, so to speak, a little bit the way that the system works using virtual addressing as well. I'm still I haven't even done any research, any proper research on this. I just have a few like loose ideas. Like I said, the first step is to move this to here without the system crashing. So once I've done that, which again, not difficult, but somewhat time consuming, then I'll be able to do what I'm saying. And I'll do some research in the meantime, probably today. I have some free time today, so I might do that. Hey MX. Not sure why you're sorry for being late. You're not in school. Don't worry, I'm not taking attendance. I actually haven't even decided what I'm going to do today. I had some network issues again at the beginning of the stream. I was looking at laptops for a bit. And now, I was talking about how I got virtual addressing to work, how I want to keep improving it. Like, okay, it's pretty much what I said yesterday. Get it to work properly, and then optimize it. That's the 3 steps. So step 1 is done. Step 2 is what I need to work on. Step 3, I need to research and do. But yeah. Don't worry, you're not missing out on anything. We're just getting started now. So again, I haven't even decided what to work on. Yesterday, what I did work on stream, not a whole lot of coding, but it's on a different branch. Designing a file system. Again, in the same manner. Design something that theoretically works, then get it to work properly, then optimize it. Actually, I am going to do one more thing related to this. I wrote down like some simple structures for how the system is going to be structured. But let me see if I can like make a graph for what the file system is going to look like. That would be pretty cool. Because this graph is not amazing. All right, that way I can explain the way that the file system is going to work. It is going to have a header. This header is going to contain a, can you make a video about your file system? Would it work on other OSs like mine if I implement it like you? Yeah, it would work. But yeah, I haven't really implemented it. So yeah, probably everything that I say, like yesterday was the designing phase. When it actually comes to implementing it, I'm probably going to realize some issues or some things that can be done better. And then on top of that, I'm going to want to like purposefully look into ways that I can make it better. The header of the file system will have a bunch of useful information, but the important part is it will point you to the root directory. The root directory is going to have the only file system, so long as I'm working on the Raspberry Pi, no, that's not going to be an option. until, you know, Banana Pie approaches me and is like, let's design a board together for your operating system, then I'm stuck with the FAT32 for a little bit longer. Genuinely, if anyone has any connections with like hardware manufacturers, please let me know. Because I genuinely don't want to use any pre-built hardware ever again, or any pre-built software ever again. I just don't want to. Like I said yesterday, I'm starting computer science over. The RIP to the old one, it's computer science 2.0. We're starting over. Okay, so the file system is going to be made out of a list of files. But it's a limited fixed number of files. So it's going to have a continuation of the root with files 4, 5, and 5 will be marked as last. So there is no other file, and oh, 0 erases. I didn't know that. I was trying to write a 0. All right, so that's how it's going to work. And also, for example, you can mark a file as deleted. Until it can be overwritten, it is just going to be marked as deleted. Okay. And then a file itself is going to have like file 1 data, and then a continuation of that data stored somewhere else. No, not root. What can I call this? Let me call this one entry. And then another one called in, oh, well, like, all right, so this doesn't make a lot of sense, but I'm going to explain it once I actually like finish building. The graph. Not that. We're going to copy this. Four and 0 on the next. All right. Okay. So this is an example of how the file system works. So the file system has a header. This is always going to be a fixed size at the beginning of the file system. Like most file systems tend to have a header. The header will have a pointer to the root directory of the file system. So you will follow that pointer and it will take you to the sector or the chunk, because it's divided into chunks, which are multiple sectors of a disk. A sector is 512 bytes. So we could be talking about, I don't know, chunks that are 4 kilobytes, for example. That seems like a good size for them. Then you can fit the contents of them inside a page. So yeah, that would be a good size for them. Okay, so it takes you to the chunk that is the root. You go to that, and inside of it, you will find a list of entries, which I believe I made 128 bytes each. So the size of how many entries there are per chunk depends on the size of a chunk. The entries are just going to have the file name, I believe limited to like 95 characters. Then they're going to have a list or a pointer to an entry and a pointer to a list. If the file is small and it fits within a chunk, then the entry will just point to that chunk. If not, then the entry will point to the first chunk of the file, which is where you will find like its header and whatnot. But that depends on how the file itself is structured. But yeah, it is just going to point to the beginning part. And then you're going to look at this other pointer called a list pointer. That one will point you to another chunk, which will tell you where the rest of the file is located in an array. So you can go there and there. I just realized I didn't copy the inside contents. I just copied the squares. So you and you come over here and then over here. All right. So it will tell you, okay, so go to this. This one here will point you to the first entry of the file. This one here will point you to the other entries. Each element of this list will point you to the next entry. So this one's going to point you to the second one. This one's going to point you to the third one. If that's still not enough, keep in mind you can fit like a lot of pointers inside of 4 kilobytes of data. But if that's somehow still not enough, the last of the pointers will point you to another chunk similar to this one, where you will find even more entries. It will take you to that one. It will take you to another entry, and then its next step will be 0. And the same thing actually happens with the directories. Like I said, you can fit some entries of a file into a chunk, but maybe not enough. So at the end, we're going to put a pointer to another list that continues the directory. You can also mark an entry as deleted so that you can reuse it later on. Although it does have some fragmentation. Because like, for example, if I deleted file 2 and file 3, then I could just move file 4 and 5 directly here. That's currently not a thing, so there is going to be some level of fragmentation. But, oh well. We can even introduce like some defragmentation in the driver itself. I don't know. That is how the file system works when reading it. When it comes to writing, obviously it follows a lot of the same principles, but then again, you also have to consider whenever you need a new chunk, that chunk needs to be made available somehow. And the way that I was thinking for that, not the most efficient. This is okay for memory allocation, like in RAM. Probably not the best system when it comes to a file system, but I don't know what the best would be for a file system, so I'm just doing what I know. Like I said, make it work, then make it work well. The header keeps track of a chunk that is empty, the first chunk that is empty. That chunk itself will have a pointer to the next chunk that is empty. You will follow that until you reach a pointer that is 0, at which point you reach the last one and you use this chunk. So you need a new chunk, you follow this list until you reach the end. And then you mark this one as a 0 because it's no longer pointing to anything. And then you use this chunk that you found. So a free list, if I'm not mistaken. That's what I called it in my system because this is how my allocations also work. Well, this is how my, what is it called? My allocations within a page work. Then allocations of pages are done differently. I wonder if I can make a similar system for allocations within pages. But yeah, this is the way that it currently works in the system. This is the way that I designed the file system to work. All of this, again, to be improved as we go along. Can I ungroup it? Oh, there's gotta be a button for that somewhere. It's so nice to participate in CTF and the infra to be down. Oh shit. Actions. Is this ungroup? Ungroup. I just went you. Thank you. You are out. Can we just... Interesting. Genuinely starting to like this kind of like system for keeping track of my tasks more than Jira or any of that kind of stuff. Even like a to-do list. I'm enjoying this a lot more. All right, so that's the way that it's currently designed. I don't know when I'm going to start implementing it. I don't feel like doing that today because I don't really have a use case for this file system yet. So I like the idea of having it designed. I like the idea of refining that design for a little bit. But I don't like the idea of implementing it just now. I'm going to give it a little bit more of a spin. And like I said, I'm going to focus more a little bit on architecture and how I build my system. So I'm not just going to start implementing things immediately like that. Okay. Well, since I'm using this for for tracking tasks at this point, there's an ad coming up on Twitch. During the ad, I'm just going to quickly write down what I need to do for virtual addressing, and then we'll pick something to work on today. So yeah, it's been an hour, and finally the work actually starts. I'll be back in 3 minutes. Well, I'll be here. You'll be back in 3 minutes if you're on Twitch and not subscribed. Oh wait, this is just one element, okay. You know, screw it. You're out. All right. Start MMU as soon as possible. That's step number 1. And then design, provide standardized system for processes. Okay, not sure how I'm gonna, if I'm gonna do these, but like I said, the plan for the MMU, first thing is to get it to work as quick, as easy, as early as possible. That's gonna save me a lot of trouble. Even the fix for the issue yesterday, the fact that I could only run one app at a time is technically a hack because I don't have this right now, because the system uses identity mapping until it doesn't, and then it's like mixed between two different ways of doing things, and that requires a bunch of like hacks. The device, I guess Raspberry Pi. I wish it wasn't. I'm starting to not like the Raspberry Pi, but yeah, that's what it's for. That or a virtual machine. All right, so plan number 1 then is to only use virtual addressing from now on. So start up virtual addressing as quickly as possible. And then after that point, see how I can use virtual addressing to my advantage. Raspberry Pi 5, yeah. It has major limitations because of the way that the 5 is works, and because they deprecated a bunch of stuff. And the Raspberry Pi 4, although I just got a Raspberry Pi 4 recently and I realized that it doesn't fully work on it. XHCI has limitations, so I'll have to fix those. But yeah, 4, 5, and technically 3B, though I haven't bothered with that one too much. Yeah, so once I have virtual addressing, I can plan on seeing how I can use it to my advantage, like I said, to provide a somewhat standardized way that applications work in my system, and even a standardized way that the system itself is laid out. Again, not even entirely sure what that implies. I'm not going to give any examples. If you thought of any examples when I said that, then good for you. But I know very little about this topic. I haven't done any research. I haven't really explored the possibilities of what I can do with this. But, well, one example that I said before is how ECS takes advantage of sequential data. So we can use virtual addressing to make data sequential as much as possible. That's one example of that. But how much further can I take it? What other applications are there for it? I don't know yet. We'll see. So I might even, like, these two figure out on stream. This one probably not super fun to work on. And because of that, then I'm gonna wait until before I do a modular kernel, because I feel like if I make a modular kernel relying heavily on virtual addressing, that would be pretty cool. Same thing for the bootloader. Maybe the bootloader sets up the virtual addressing. We'll see. That leaves me with very little to work on, because everything is dependent on this. The 9P protocol for file system is... All right, let me take a second, because I said that the modular kernel relies on virtual addressing. So let me move over here for a second. Okay, so the modular kernel relies on virtual addressing. Building a file system doesn't rely on having a networked file system or a distributed file system, but it would be nice to build kind of both. And to use like the existing 9P protocol, but with a different dialect, because 9P is a cool protocol for file system sharing, but this stink of Unix is in the air. You can really just... The 1960s just come rushing back to you, even if you never existed in the 1960s, as is my case. The 1960s just come rushing back when you see 9P. Well, 1990s, because that's when it was created, but very heavily inspired by Unix. And the dialect that I'm using, if I'm not mistaken, is the 9P dialect used by Linux. So there's like file permissions and users and shit. There's so many like concepts that are completely outdated when it comes to a networked file system, or just any file system ever. But yeah. So, well, this one is a virtual file system, and this one is a physical file system. Yeah, they don't rely on each other. Never mind. Let's just say that. They don't rely on each other. Then the bootloader stuff would be cool to design it based off of, again, the virtual file system. Maybe the bootloader is the one that sets up the file system for you. And... or the virtual file, not the file system, Jesus, the virtual addresses for you. And then the kernel works on a somewhat like standardized view of memory, to put it in one kind of not very clear to understand way. Whoop, you can do that. Cool. And then there's this, customizing the system using a runtime app. That's just something you can do. And then there's testing. I might do this today actually. This might be an interesting thing to work on. Because as it stands right now, the system, I can think of one major issue when it comes to freeing memory. And it's the fact that you can allocate full pages of memory. Even for like a user-lent process, you can allocate full pages of memory. If you do, the way that the allocator works doesn't keep track of those full pages of memory. And so when you go to free those full pages of memory, you can't. And also, when you allocate a certain amount of data, that gets like, because of alignment things, you're actually allocating slightly more than you asked for, but then you're not freeing slightly more than you asked for. So it would be cool for me to detect these cases, which I know about them because I designed the damn thing, but there's probably some other issues that are happening when it comes to allocation, for example, that are happening that I'm not even noticing. And some more issues that, yeah, I probably need to notice, need to know that they're there and test them and figure them out and fix them. So this might be something that I want to work on today. Testing and stability. Starting with detecting those issues that I mentioned and fixing them. Or at the very least detecting them and then, starting to work on a fix for them. So essentially we want to write some unit tests for my system. Hopefully that's going to help improve stability a little bit. So, how do I go about doing that? Well, I'm going to create not a file, a folder inside the kernel called tests. Inside this folder, I'm going to create a file called alloctests.h. And I'm just going to pragma once. I'm going to include all types .h, and I am going to welcome Avocado Violet and Raiders. Welcome. How are you guys doing? Okay. Don't need any more hashtags here. Okay, this is what I want to do. I want to have some allocation tests. So alloc tests.c. We're going to include the alloc tests.h. We're going to include this, and we're going to return travel. And then, let's see, how do I do this? My voice is calming, thank you. And thank you for the raid again. And good night. Is your OS agentic? Hell no. Thank you. And as funny as I find it that Windows wants to be agentic, it's also very sad for the people who don't know better than to use Windows. But I'm laughing at the whole thing. All right. Although I have to say, their system is probably more stable than mine, which is why I'm building these tests, hopefully to improve the stability of my system a little bit. Okay. So, but let's just put a print in here that says like, I don't know, running tests for allocation. To call this a... yeah, actually, I wouldn't count on it being more stable than mine. It's super easy to break mine, but it's super easy to break Windows, so... yeah. Imagine being a DevOps at Microsoft. Oh, shit. The other day, when Azure was down, I was watching TikTok, and I came across a Microsoft TikTok live. Because apparently they go live on TikTok. And these two poor girls... oh... first off, they were vibe coding a website that would tell you like your pop culture Halloween costume, because yeah, this was like at the end of last month, based on like a personality quiz. All of it was vibe coded through VS Code. All of it was like agentic vibe coding, blah blah blah. First off, I felt really bad because, well, no one was actually paying attention to them doing that. Everyone in the comments was like, Azure is down, fix your shit, Windows sucks, I love Linux. Just like, random comments like those. And then also the shit that they were building like did not work, because fucking obviously it didn't work. But I felt really bad for these two girls who were like just doing their jobs, and they just so happened to work at Microsoft, and it sucks to be you, to be honest. Like, yeah. Everyone was saying like how much they hate Windows. Mostly they were complaining about Azure being down, and you know, Minecraft was also down. So a lot of people were complaining that Minecraft was down. The biggest thing was fix Minecraft, fix Minecraft, fix Minecraft, fix Minecraft. Azure is down, Azure is down, Azure is down, Windows sucks. But yeah, must have been a really uncomfortable thing. They were forced to stream as like some promotion. I think they stream regularly. I think this was on a Tuesday, and 2 weeks in a row I saw them streaming. Like at the same... this fucking dog, bro. There's rules against nudity. Stop doing that. I think they stream every week, but it's not always them. Like it was these two girls this one time, like right before Halloween. Then it was like some guy the week before that. Also, I don't know if they looked like they were at an event or their corporate office just has that much fucking advertisement on it. Because corporate offices, you know, if you've ever worked at a corporate office, you know how much advertisement for the company that you work for you're gonna have in a fucking corporate office. It's horrible. But it genuinely looked like they were at a conference or something, based on just the amount of like Microsoft branding that surrounded them. I need Microsoft Mojang Jira ASAP. Is this their offices? I just realized I'm one letter away from finding a product of theirs, because I wrote offices. It didn't look like this. It didn't look like this, so... maybe they were at a conference live streaming from there? I don't know. It wasn't this colorful. And they were talking about living in Silicon Valley. So one of them was from New York. She was talking about the difference between like New York and San Francisco. So I'm assuming they were in like their headquarters. But I have to say, based on these pictures, hard to tell if they were there or not. Then again, they probably have headquarters all over the world, so what do I know? Our department tenets are ugh. Also, if you're a corporate worker, you know about like mandatory training when they're like, don't make your password 1234. Making your password 1234 is unsafe and can lead to data breaches. Also, do not make your password 12345. This is not more secure. Compliance training, yeah. I was actually told yesterday that they changed the platform that we use for compliance training, and I actually looked on the platform that they said and I couldn't find it, so I guess I'm not compliant. Whoops, sorry. I'll probably look at it on Monday. Also, very common, I feel like, that kind of training is done through skits. The most unfunny, horrible fucking skits you've ever seen. Oh boy. Because, you know, it's boring to say your password cannot be 1234. So they're gonna make literal skits out of what happens if someone makes their password 1234. And yes, it's gonna suck. And yes, you're gonna have to watch it. You're literally required to watch it. You're only allowed one pen and it's placed fine by outline colored tape on desk. Ew. Yeah, at least I work from home. I don't know about that. All right, so we're going to include my allocation. Wait, this is not a void. This is a boolean. That's the mistake I'm making. I genuinely cannot imagine doing like PR for a big company like those poor girls were doing on that live stream. Like, oh boy. As a person who codes live, I could never fucking do that for a company. Especially Microsoft. I would just be too embarrassed. And yet I'm sure people actually enjoy doing that. Some fucking how. Okay. So. It's been an hour since their info is done. Nice competition. What CTF is that? 5S, lean workplace. Sort, set in order, shine, standardize, and sustain. If you don't explain this in an unfunny sketch, I don't get it. And if it's not like 20 minutes long, sorry, but I don't understand it. Amateurs CTF, I guess the name checks out now. Yeah, that definitely does. Cool teddy bear. We're CTF run by the students from Les Amateurs CTF team. Our competition mostly targets beginners, includes middle and high school students, although we hope that it's also an enjoyable experience for people of all experiences and backgrounds. If your company has a department dedicated to that, you're in 5S called hell. Jesus, seriously? Oh shit, okay, we don't get to log in. We don't get to see what the challenges are. That sucks. We're going to panic the system if you fail running tests. Fuck it. Hey, day 4 of that. Are you gonna go through all the letters? Except I'm pretty sure I've actually never seen you comment anything besides that text-to-speech every time I stream, so I guess I'll find out in 22 days. 22 work days, I guess. Clean up manufacturer, assembly, workplaces. Yeah, that does not seem like something that you would find in a software company. And yet. All right. Now, if I run make test, I want to make it depend on case shared. I want to make the kernel based on load address. Can I make, well, default actually. You can actually change it if you want. XHCI context size is standardized as well. QEMU, we're gonna make this one true. Test true. Wait, is it true or do I write 1? Let me see what I did here with QEMU. True. Okay. All right, and test true. Cool. And in the makefile for this, pretty much want to do this. And this. And now, let me see if I did that correctly. I do make test. Okay, yeah, I didn't import the thingy, so obviously that wasn't gonna work. Oh, and panic takes 2 arguments. No, we don't care about the second argument right now. Right, it doesn't run the system, so I kind of forgot that part. Test run failed. Good. Which means it actually succeeded because I inverted this condition, but it works. Cool, we have make test. Now I gotta actually make it work. Am I doing this in MMU branch? Failed successfully. Very accurate, actually. I'm doing this in the main branch. That's cool. That's cool. That's exactly what I wanted. All right. So we added the test. We added the kernel. We added this. We added the test runner. Oh, and just to make sure. Running tests for allocation. Very good. All right. That's test. That's how you spell that. Cool. Let me actually write one of these tests. Let me write an after free test. We are going to allocate some memory. Well, not that much. We are going to write to that memory. Well, let me make it like a UN 64 even. Actually, hold on. I already wrote this test. Did I keep it? I deleted it. But if I go back far enough... Hold on. Prefer using GitHub for looking at file history. But if I go to user, default process, and look at my history, the only thing that's sad about it is it doesn't tell me exactly what I changed. But this should have what I want. Yep. This shit. That's exactly what I want. Okay, we don't want to use printf. Def bead, what dead beef, then we want to return false. Maybe I want to create like an assert function type of thing. All right. We have a test and it seems to have run correctly. Maybe not. Well, feels like, yeah, I kind of forgot an important part to actually call the function. It worked correctly this time, though, yes. Okay. And now I want to make a static inline boolean. Assert true, assert not equal. Fuck, hold on. I don't know how to do this. Okay, let me do assert true. Okay, I should be able to do something like this. Okay, so assert true that the condition is that A3 is not equal to, no, it is equal to that beef, and use after free failed. All right. Hey, Sam. Yeah, it has been a while. How you been? Right, let's see how that goes. Well, it's not gonna fail. Use after pre-failed with this value. Yeah. Oh, but then, yeah, I forgot that. Well, actually, you know what? Here's what we're going to do. We're going to define assert true with a condition fmt arguments. It's going to be an assert true func with the condition. Bro, what? fmt and format for this is this. And if this fails, then return false. And that way, hell yeah. Now, which one of these did I book? Okay. Deleted that letter. There we go. Cool. I love macros. I swear to God, I love macros so much. They make working with C pleasant. It sucks. I am coping a little bit when I'm like, oh, I love C. I love working with C. And then I have to like hack the shit out of it to make it nice. But yeah, X macros. Well, I haven't heard of that. I have heard of that. Not that I remember what that is. List like structures of data or code. Oh yeah, somebody brought it up a few days ago. Hell, you can use it for like reflection. Is that the name of it? Reflection? Or is that just a specific name that some programming language uses? I think that's easy to understand. But yeah, with like the hashtag thingies inside the macros in C, you can use them for reflection if you want. I'm using them quite a lot in my ECS game engine. It's only a little bit crazy. All right, I have my first test. And I'm gonna delete this because I want to have as few prints in here as possible. Likewise, we can just do an assert false with this. And I might even be able to do an assert equal if you do element 1, element 2, element 1 equal to element 2. It's not quite reflection since it happens at compile time, not runtime. You could use this in conjunction with some other stuff to get reflection at home. Yeah, but like in practical terms. All right, we got assert equal. And neck as well. Because that way we can test that it actually, but hold on, if you don't change the condition inside of it. Or, you know, what's better is to put that here. And also here. All right. But we do need to assert that they're equal. Cool. Where's my test runner.h? No, not even in here actually. Test.h. pragma once and include types. And we also want to include syscalls.h. And there we have it. But now obviously you don't have it anymore. So instead, test.h. Or, you know what? Test.h. Cool. I thought it would be harder to do this, if I'm completely honest with you. I'm a little surprised by how quickly I was able to get a test up and running. Cool. I guess. All right. Okay, the thing that I actually said I wanted to test is... Come to think of it, oh, yeah, okay. Hold on. Test full alloc free. I should probably give it a more. On page k alloc free. Okay, so well, it's not a void, it's a boolean. Yeah, syntax is not the best there, but whatever. Okay, so we're going to use the page allocator in this one. So that's memory page allocator. We're going to palloc. We're going to allocate a page for mempriv kernel. We're going to make the page read write, and we don't want to allocate a full page. Okay, then within that page, I want to allocate some more memory. So I'm going to use the kalloc function using the page allocator that I just used. And inside of it, I'm going to allocate enough memory for an entire page. I'm going to align it to a page boundary. And again, I'm going to make it kernel memory. I'm not even sure if this level attribute is even needed anymore. But yeah, there we have it. Then I'm going to want to p-free the page on page size. And I'm going to assert that the memory that I freed okay. So I'm allocating a page allocator. I'm using a page allocator. Then within that page allocator, I'm going to allocate a lot of memory. Or it doesn't even have to be like a page size. It can just be like the size of uint64. I'm allocating a uint64, so 8 bytes, but I'm aligning them to 4 kilobytes, which means to a page boundary. So I have to allocate an entire page for that. Then I'm going to free the page in which I allocated, at which point this memory page is not going to be freed because there's no pointer to it in a way. I know that because it is at a page boundary, it is not being kept track of inside of this pager. And so it is not going to be freed. But at the same time, I also want to create a similar test. Instead of being aligned to 4 kilobytes, I'm going to align it to 16 bytes even. And check that it has been freed. Oh, but its value is not going to be that beef. It is going to be something else. It is going to be, I believe, a free list. So that's not going to be super helpful. Yeah, I think that test is wrong, but we'll get to that. All right, it failed, which is a good thing. Full page not freed. So it actually failed out. Just so I can move them around, I'm gonna do that. Oh, it actually failed with an exception. So it crashed. Cool. Which part of this crashed? Probably reading the memory. It would make sense for it to fail when reading the memory. Oh, because that page is unmapped now. So you can't really do... Well, no. Yes, the page is unmapped. So I shouldn't be using p-free. I should be using just k-free. For mem and its size. Memory not freed 8. Except that memory is freed. Because it tells you the amount of memory that was freed. When you free memory, yeah, it has the dead beef stuff inside of it, but it also has that's why here I'm allocating 64 bits. 64 bytes, I mean. Because the first two values of that are the free list, kind of similar to what I said earlier in the file system. How there's pointers to the freed memory. So the freed memory doesn't just contain dead beef, it also contains those pointers. It has the size of the memory that was freed and the like amount that was freed. No, the amount that was freed and the pointer to the next block of free memory. So what I'm expecting to find is the size that was freed. And now it fails because of full page not freed. So okay, this test succeed, this one fails. Which is what I expect. But there's more that needs to be done. There's another test that's probably gonna fail. An alignment test. And these two are the ones that the two conditions that I wanted to check against. So test alignment free. Okay. I am allocating 8 bytes on a 16-bit boundary. But what if I allocate, instead of that, I allocate 8 bits on a 16-bit boundary? The amount that I expect to be freed is actually the alignment amount. And that's not gonna be right. Also, this shouldn't be cast to a 64-bit. I need to see how much it needs to be cast to. That's taken from the memory page allocator. Free block. 64. It's a 64-bit value. Okay. So essentially what I'm testing is that I allocate 8 bytes, I free 8 bytes, and it tells me that it freed 8 bytes. So far it's correct. However, when I allocate 1 byte on a 16-byte boundary, on a 16-bit boundary, I'm actually allocating 2 bytes because of the boundary thing here. So when I free only one of them, I'm not freeing all 2 bytes. I'm only freeing one of the 2 bytes. So I believe this one will fail. And I'm not gonna lie, I'm writing the tests right now, but I don't know about the fixes for these 2 tests. They'll require a little bit more work. Memory not freed 1, when it was expecting it to be freed 2. So yeah, that's correct. Yeah, because what's happening is I'm allocating more memory that's being requested because of alignment things, but then I'm not freeing as much memory as I allocated. So I'm wasting memory. It's not an issue. Well, it's an issue. It's an efficiency issue. It's not really it's not going to cause problems, but it is going to be not ideal. Okay. That's cool. I was able to detect the 2 issues that I wanted to detect, that I knew that were already happening in the system. But I don't know how to fix them, to be honest. How are we doing on ads? Okay, it's an ad in 8 minutes. And connection's working fine. Cool. Gotta keep track of how my stream is doing because it hasn't been amazing lately. But so far so good. All right. So now that I wrote these tests, we're just gonna ignore them, pretty much. That's the plan. Because, yeah. No, one thing I need to test is, does the system still run without the tests? No, it doesn't. I probably should have checked that earlier. I need to be a little bit more careful when I commit to main directly to not do this type of shit, because, yeah. Test should not be defined. Why do you think test is defined? If test true, then CPP flags. Yeah, but tests is not true. Oh, but it doesn't have a default. That's kind of my bad. Nope. God, I hate working with make files. I feel like they're not as clear as they possibly could be. Every day I get closer and closer to make my own compiler. All right. Test is false. So when I run make run, I just make with mode make all kernel with no value for test. So why is it defaulting to true? That should not happen. Oh my god. Make your own compiler? I will at some point. Okay, that's one makefile. This is the makefile instead of kernel. It checks if test is true, which it fucking isn't. I swear to god, I hate makefiles. Oh my god. Maybe I should start by making my own like makefiles and then making my own compiler. Because what the shit is this? It's so confusing. It is so confusing. Yeah, but why would it default to true? But also, I just copied the QEMU one and changed the name. Yeah, no, that syntax is not right for makefile. That's right for shell, but not makefile. I swear to God. You know, when I wrote the QEMU thing, the exact same thing happened, so. Real quick. Alright. Oh, it's just if, not ifdef. Well, it's also ifdef. Oh, maybe it's not supposed to be ifdef. Let me try with if. Maybe that's my mistake. That'd be stupid. Oh. Alright. Works without. Doesn't work. Motherfucker. I swear to God. What else is going on with... Hey, all of them are checking if QEMU. The makefile is simply testing. They're not doing ifdef. They're just doing if. With a default value of true, I make a default value of false. Then in the makefile, I explicitly set test to false. And here explicitly set it to true. Except maybe this, maybe here I need to set it. All right, tests work again. Who knew the most complicated part of this was going to be the makefile? All right. Clean. Did any do J8? What happened there? That's supposed to be with test, so it doesn't work anymore. Nope, that wasn't with test. All right. Okay, I realize my mistake now. Is that where's the one that creates the file system? It's in all. Oh, because this makes all. Okay. Yeah, we're here with test. I'm just compiling the kernel. That's not correct. Test should be this. Doing this with this. Then it should be here, passing down the value of test instead of hard coding it. All right, let's see now. Try test. Didn't work. Already didn't work. Wait, so don't pass that. Maybe. My God. Nope. Oh God, I hate make files. I'm genuinely spending more time figuring out how to compile this than I am just building the damn thing. Took me like 10 minutes to build tests. There's an ad coming up on Twitch, by the way. I'm going to take a break during that, and then I'm going to come back and fix this. Definitely fix it. Okay, I'm back. Unfortunately, the damn makefile isn't working. And now I gotta figure out why this makefile isn't working. Oh god, why are makefiles a thing? Okay. Here's the way I see it. I have a variable called test. It is false by default. But when I go inside make test, I set it to true. Oh wait. Well, maybe not. Okay, hold on. Let me see how this is doing it. Yeah, I think I may have been missing that. But anyway, I set it to true. I use it. I don't use it here. Alright, maybe it's not makefiles, it's me that's the problem. I feel like the build is taking like 10 years more than it should. Also, where's the error? I'm not seeing the error. Where's the error exactly? Okay, it built with test to true. That's cool. I'm still not seeing where the error is. But, alright, let me check this. Okay, so this works. But I would love to know what the error is. Alright. At least it works now. I'm not happy, but at least it works. This is probably not needed, but yeah, we're just gonna get rid of it. Okay, so give it a default value, pass it in here, define it in here, use it with an if, not an if-def, and then actually created a test. What is that error? The input file kernel.elf is empty. What? It doesn't look empty? You know what? Whatever. If there's another error, I'll fix it later. As long as make test works, that's all I care about. Everything else can be fixed in post. Cool. So already I detected a couple errors that are happening that I already knew were happening. And I'm sure there's some other tests, that I could do, yeah. Some other tests that I could do that show me how certain things are not working. But I genuinely don't know how to fix this one. Because again, if you allocate something aligned to 64 bits of memory, no, not 64 bits, what? To 4 kilobytes of memory, then you have to allocate at the very least 1 page. And The problem with that is that you would assume that it would be getting freed when you free the page that you allocated it within. But it's right now up to the user to know that, hey, actually, no. Because the memory that you allocated is outside of the paged allocation. It is its own page. And so when you free the page, when you free this page, you're not freeing this page because you created another page by accident, just because of the alignment that you chose. So I'm gonna have to figure out like a way to do that, to fix that, to come up with a solution for that. But I genuinely don't know what it would be right now. Same thing goes for the other one. If you allocate 1 byte, then you expect to free 1 byte. But what you don't know is that you're secretly aligning to 16, well, because you're aligning to 16 bits, you're secretly allocating 2 bytes. In the same way that here, when you're allocating to 4 or aligning to 4 kilobytes, you're secretly allocating 4 kilobytes. So I don't know. I need to come up with a way to do that, to free that, to fix that. And I'm not sure how to do that. Yeah, I'm not sure in the slightest how to do that. I'll have to do some research before I'm able to fix these bugs, but at least I know they're there. That's always cool. Oh, also another thing. Maybe this is being freed. So like I need to check properly with what value is being written there. Full page not freed, 0. Yeah. Okay, so that means that it wasn't freed at all. Which makes sense because, like I said, when it's allocated at 4 kilobyte alignment, it's just allocated like a page. And so this one never even finds out that the allocation happened. So when you free this one, you don't free this one. Whereas for another one, when you are aligning to 16 bytes, 16 bits, then it does know and it gets freed. Yeah, but not sure how to fix it. And another type of test that I wanted to do is buffer overflow detection. I currently don't have anything for that. Could I? Well, mostly I care about writing past the stack and past the heap. But there's a chance that actually like virtual memory is going to change the way that that works. And using virtual memory, I'm going to be able to detect when you go past a buffer that you're not supposed to go past. So maybe that one's going to wait a little bit. I feel like if I design my system, like for example, a user process can work like this. You have the code. How do you type inside of here? I know you can do it. I just don't know how to do it. Anyway, you have the code for your... I'm not sure how I've done it in the past. You have the code for your program. Then you have the stack for your program. Then you have your heap for your program. And the way that it works right now is a little bit like this. Your program is put into virtual memory wherever you want it to go. So that's up to you. Your stack and heap are just allocated to a specific physical address, and you're given that specific physical address. But technically, I don't know. If I had to guess right now how I could do like buffer overflow detection is, I know where this starts and ends. So after that, I could put like a watch. What is it called? A canary value? I don't know. Like a check. A value that I expect to always stay the same. If this value changes, then I know that something has breached the boundary that it wasn't supposed to. I put the stack here, put another value here, the heap here, another value here. And if any of these values are ever changed, then I know that you've somehow managed to go past a buffer that you weren't supposed to and stop you from doing that, in a way. Then again, this is less of a problem with virtual memory because when you have virtual memory, then like writing anywhere outside of these three rectangles will result in an error. That's not really supposed to happen. And so it will already stop you from doing that. So maybe I won't even need it. Then again, I don't know. I need to think of that a little bit more. Because there have been cases in which the stack, because of context switching, changing the stack constantly, there's been cases in which I was accidentally not overwriting the stack, but actually overwriting past the stack and overwriting whatever memory happened to be there at the time, and then that would mess up the system. It probably led to a crash. And I never understood why it was until, a lot of GDB watches told me what the issue was. But again, based on how I do virtual memory, there's a chance that that won't even be an issue anymore. I guess I'll have to study it. Okay. Let me see actually if OS Dev Wiki has information on an allocator. Because again, alignment things, I feel like that's mostly an ARM thing, so maybe in x86 it's not that important and you don't care as much. But there's no page on an allocator? Oh, yes, there is. This is for x86. What are preframe? Well, I don't understand what's happening in this code. Okay, let me try to decipher the ancient texts known as x86 architecture. The code. Alright, I feel like this has actually nothing to do with x86. The page frame allocator will allocate frames with the first frame starting right after the end of the kernel. That makes sense. Each frame shall be managed with a byte map. So it's the same thing that I'm doing. I was hoping that they would have a different way of doing it. Because the way that pages are allocated in my system, it's just a map. Literally like, this one is taken, this one is free, this one is taken, this one is taken, this one is free. I was wondering if there was a better way to do it, but like again, could it be done through like free lists? Not sure. To allocate a page, all that is needed is to search through the array for a free page and then mark it as used. You may have noticed that this would be very inefficient, having to search through a possible number of that many pages. To speed up the allocation process, the allocator will allocate 20 page frames at a time. So most of the times it will have been done beforehand. Allocating a new page is simply a matter of getting a page frame off of an array of pre-allocated frames. Is it using... Hold on. It's using 1 byte per page. No wonder it's inefficient, my dude. I use 1 bit per page. It probably makes it a lot less inefficient. It's probably not super efficient, but yeah. Alright, but this does not help. I was looking for the allocator inside of the page allocator. Let me see. Bitmap allocator. That's the one that I'm using. The address of each physical frame is stored in a stack-like dynamic structure. Allocating a page is fast, freeing a page too, but checking the state of a page is not practical. Yeah. I saw it short and I have a feeling it's from here. It is from here. That's from yesterday's stream. If you mean today's short. Yes. Okay, this allocation method is something like what I was thinking of doing to fix the problem with the alignment things that I mentioned before. You split each area of, say, 16 kilobytes into chunks of 1 8 kilobyte and 2 4 kilobytes. Okay, I can't say I understand the structure of this sentence, but I understand the meaning of it. Which is to say, you divide the area into like memory that is going to be given to certain sizes of allocations. Then you hand out each chunk so you can find closer fits to exact sizes. Say that you have an area of 32 kilobytes, you divide it into 8 4 4 8 4 4. You can even have 1, 2, 3, even more types of layouts for each portion. Then you have more sizes to choose from. So essentially, if I want to allocate, I was thinking of something like this for alignment. If I want to allocate based on a 8-bit alignment, then I allocate to this part. If I want to allocate on a 16-bit, this part. If I want to allocate on a 4 kilobyte, this part. And then based on where it is, I know where it was allocated from. The body allocation system is the physical memory allocator of the Linux kernel. I love how poorly this wiki is written. Holy shit. It never actually explains. It just kind of like slips the concept of buddies here, and it doesn't actually tell you what it is. This is the physical memory allocator of the Linux kernel. Note that Linux has several buddies depending on whether memory is suitable for ISA DMA or is coming from high physical memory or just normal. Each buddy contains k bitmaps, each indicating the availability of a certain sized and aligned blocks of free pages. Buddy did not explain what a buddy is. Just kind of hoping that you don't notice that. It's a bad wiki article if you actually understand something from it. Genuinely, what does that mean? it it starts by telling you like, okay, this type of allocator is actually used by the Linux kernel. This is how Linux uses it. This is its specific implementation of it. But then it doesn't tell you what it actually is. It just kind of hopes that, oh, you know the Linux kernel, like you read it like a book. You do that in your free time. You just have 5 minutes to yourself. You just start reading the Linux kernel. That's what everybody does, right? So clearly I don't need to explain what this is to you. A body for end pages is about twice the size of a bitmap of the same... Bro, I don't fucking read Chinese. I don't know what language this is, but this is not English. I'm just gonna skip that one. Hybrid scheme. Allocators may be chained so that the stack only covers the last operations. The bottom of the stack is committed to a bitmap. If the stack lacks pages, you can scan the bitmap to find some. Instead of keeping track of just bits representing pages or just page numbers on a stack, use a big array of structs to represent the memory. In these page frame structs, store a single link to a next page, pointer sized, and a 8 to 16-bit information block. Oh, you did that while waiting to be born? That's the best time to do it, because then after that it's just like chores and school and then work and fuck that. Best time to read the Linux kernel is before you're born. The only wiki I know is good is for the one people made for Minecraft, though to be fair, there's more editors on on those that probably these wikis. Yeah, no, this wiki is famous to me anyway for having been written in like 2004 and not updated since. No, view history. 2023, 2023, 2022, 2017, 2015, 2014, 11, 7, 6. Not a whole lot. Then again, at no point was this understandable to someone who doesn't already know what this is. It feels to me like this wiki was written by people who have knowledge to share with other people who already have the knowledge. If you don't have the knowledge, that's not their problem. Why would you come to a wiki to learn? No, you come to a wiki to boast about the knowledge that you already have with people who also have the same knowledge. That's the way that a lot of this wiki feels like it's written. Feels like it's been written by people who want to gatekeep the knowledge, essentially. If you know it, if you know, you know. It feels like if you know, you know. That's how the fucking wiki was written. Okay, back to this one. In these page frame structs, store a single link to a next page and 8 to 16-bit information block indicating its status. Also include the virtual page pointer and the TCB to which the page number belongs. Keep pointers of each type of page to both the start and the end of their list. This way you can easily display information about their content, the amount of pages for each type available, mix types, allow for dynamic cleaning threads, do copy on write fairly easy, and keep track of for an example implementation, see Atlantis OS 0.0.2 or higher. Oh, okay. Ain't the body system just exponential buckets? I genuinely don't know what either of those things are, so I cannot tell you. But like, I mean, the word buckets and the vague understanding that I got from this, I feel like, yeah, maybe is the answer that I want to give you, but I genuinely have no idea because I'm just talking out of my ass. Because I came here to get some knowledge and I got none. I feel like I got yelled at instead. Then a virtual address allocator. No, we're not doing that. Let's see the tutorial. Malloc. The first step is to get out a pen and paper. I don't mean a keyboard and text editor since you can't draw diagrams. Well, this was clearly written before Excalibur over here, but I get what you're talking about. Sketch how the memory will be laid out on paper. Don't start writing your allocate function straight away. That should be one of the last things you. Oh my god. Bro, you're not the fucking Karate Kid. Like, no. Oh, you want to allocate memory? You want to write an allocator? Well, first. Oh, no. Put the fucking code editor away. A compiler, throw it in the trash. You're not going to use it. First, you're going to spend 5 years connecting with the memory. Okay? Here's how we're going to start. You're going to grab a stick of RAM. You're going to lock yourself in an empty room with it for 2 weeks until you guys become one. Then you're going to get pen and paper and you're going to lay out the memory. Then you're going to get light switches or like anything that can be used to represent binary. And you're going to code your memory manually. And you are going to allocate it like bit by bit. And only then, once you have completed your training, can you write the fucking allocator. Bro, I didn't use pen and paper to write an allocator. Sorry. Yeah, you gotta connect with the paper first. I forgot about that part. My god, some people take themselves too seriously, I swear to god. Let's face it. Unless you are Linus, you're not Linus. It's okay to come up with something that isn't working perfectly. Like, there's a reason I was able to write these 2 tests that fail. I think it's these 2 anyway, I'm not checking. So quickly. Because I've known about these limitations of my allocator for a long time. And I wanted to use them as an excuse to write tests so that, you know, if my allocator ever breaks in the future, I can just test it and make sure that it doesn't. Is my connection dropping again? For fuck's sake. What is wrong with my internet? Why am I at 9,000 bitrate? Alright. I think the stream went down for a bit or didn't work too well for a bit. Now it seems to be back. YouTube never even realized I was having issues. Twitch always thinks I'm having issues. And yeah, I have to say, all the software involved in streaming feels incredibly glitchy. Internet issues aside, that's probably not related to the streaming. That one's probably on my ISP. But all that happened is you teleported. All right, fair. Actually, when I was editing that short that I posted today, I realized like there's a... No, I actually took 2 shorts. So the one that comes out tomorrow, I guess. Spoilers for tomorrow's short. Not that it's anything new, literally just like taken from the stream. But there's a part in which like I glitch for a second because the stream went down when I was talking. Anyway, all right. Yo, I'm going to have to end the stream, grab a stick of RAM, connect with it on a spiritual level, then come back to this page for the next step, in which, like we said, connect to the paper on a spiritual level, connect with the pen on a spiritual level, and only then can I actually start writing my allocator. Remember, this is your operating system. Plan it how you would like. You know how I would like it? Not with pen and paper. The important thing is to start from an overall view, not sitting at a keyboard with a blank malloc function expecting to know what to do. What to do. What to do. I wish this person had spent a little bit more time at the keyboard. And I don't know. I swear to God. Oh God. It really feels like I'm... What's the name of the Karate Kid? Mr. Miyagi. It really feels like he's the one who wrote this fucking tutorial. You want to know how your memory is stored? Then you can go onto your allocation function. Close that text editor. We're not done with that pen yet. Close the fucking text editor. How dare you? It's been a year of designing an operating system and you think you're gonna be coding it? Pfft, please. I actually find it like incredibly difficult to just design things without building them. Not gonna lie, I'm surprised that I was able to design a file system yesterday because I didn't write a single line of code for it, and usually that doesn't work for me. Also, when I wrote my allocator, it was on a plane. The Wi-Fi wasn't working. I didn't have pen and paper with me. I just, took my code editor, started coding, and then committed. And then when I landed and I had internet again, just pushed the commit. Bold of me, I know, to just write an allocator without pen and paper and without consulting with the ancient ones. But yeah, I did it. No, but I love that also. And once you know how memory is stored, you can go onto your allocator function, but you're still not using the code. You find free blocks, you mark it as used to return its address, then break it up. How do we find a free block? Start with a pointer to the beginning of free memory. Does this header have an end of memory status? Yes, allocate a new page. No, return an error. Does this header say this memory is free? Yes. Is address of next header minus address of this header minus size of header larger than the size wanted? Yes, we found a free block. No. Okay. Once you have found one, set its bit to used. Its space found significantly larger than the space needed, then it's generally a good idea to split it up. Okay. This may be what I end up doing. Aligning, but then splitting up the memory. No, the stream is not ending. That was a joke. Sorry, I didn't clarify. Unless the internet fucking goes down again because it's trying to. That first fit, good for time complexity, bad for fragmentation. Yeah, no, I have that issue. That's actually why I'm looking into this, because I have that issue. I wrote a test that shows that I am freeing less memory than I'm allocating because of alignment and because of fragmentation. So, okay, maybe splitting up the memory could be a fix for that. Like, if I'm requesting 1 byte on a 2 byte alignment, I'm right now allocating 2 bytes. Then I'm freeing 1, and that's wrong. But if I allocate 2 bytes, but then in one of them I put in the free block, and I use that, except that's actually not enough memory, so that's a problem. Because if I put a free block in there, that's 16 bits. 16 bytes, not 8. Whereas I'm talking about only 8 bytes. Yeah, this doesn't make sense, but maybe. Maybe I can fix it that way. Anyway, cut it in half, then half again. So yeah, maybe splitting it is a good idea, so that I don't allocate more memory than I'm being asked for. But maybe it won't work. I don't know. Maybe there's going to be some cases in which it doesn't work. And either way, in order to align yourself to a 16-byte boundary, you're like skipping a little bit of memory, and that little bit of memory is not being kept track of. And that little bit of memory is going to be lost, so to speak. But okay, potential fix right there, I guess. I just have to think about it a little bit more. I need to get some pen and paper. Okay, so that's it for the allocator. Then free, don't program it yet. You're not done. You cannot start building until you've figured out every single aspect of your operating system. Actually, the legend has it that the person who wrote this article still hasn't written a single, even like hello world for their operating system because they're not done designing it. They haven't considered every single edge case in pen and paper, so they're not ready to start coding the operating system itself. But once they do, it is going to be perfectly designed. Or actually implementing the thing, they're going to realize that, oop, I didn't consider that case. And so they're going to have to make a bunch of changes. You need to find out where about your bitmap or which header is associated with the address you're giving. I don't think you can do anything about that alignment memory to BH. Maybe. I think maybe there is. Like again, splitting it could work. Somewhat, kind of, maybe a little bit. Yes, no, I don't know, but it's not the easiest. Yeah, I need to think about it a lot. I need to get pen and paper. No, what I need to do is start messing around with the allocator until it works, or until I give up. Okay, no, hold on. The entire time, I thought at the very least you would have started coding here, but no. You're just designing the free, and then, only then, you can start coding. Once it's written, you should try it out in a simple sandbox environment, such as allocate around about 5 random sizes, deallocate a few from the middle, reallocate them, and then print out all their memory addresses at each step, and take the time to work it out in paper to see if it's doing it correctly. The main problem I've had is with the freeing. Also, you wrote your operating system like in code? Getting a little bit ahead of yourself, aren't you there? I feel like you are. Which I had to print out every step to the screen to find the bug. Which ended up being a equal sign instead of a double equal sign. Fucking amazing. Don't copy someone else's code. You can copy the basic theory, but plan how you want it to work for your OS on paper and implement it your way. I cannot think of a single operating system in which your allocator needs to be like vastly different from anyone else's. I genuinely cannot think of one reason why you would be like, well, hold on. My operating system is actually special, and so my allocator doesn't work like other allocators. Okay, but at the very least, once you've developed an entire operating system in pen and paper, you can start coding it at the end. And then you're going to find a bunch of bugs because you accidentally wrote an equal sign instead of a double. Ooh, what a tutorial. What a tutorial. It was actually written by like multiple people. Yeah, tutorial my ass, yeah. Not much of a tutorial, actually. That's another thing that I completely skipped over. It's like, oh, do it in pen and paper. It's just all of this to tell you, do it in pen and paper, then code it. But not actually telling you how to do it. I hadn't even considered that. But now that I think about it, this is the closest we come to getting any sort of like actual logic. Not even code, just logic in this tutorial. Anyway, computer nerds in the early 2000s, what do you expect? Never said anything about the data structure used for bookkeeping the memory. Excuse me? Isn't that on your pen and paper? I mean, on your paper? What the hell? Haven't you written an entire book on how your operating system is going to be designed? It's different for every operating system, so I cannot tell you how it's done. You need to figure it out on your own. What a beautiful tutorial. Absolutely loved it. Every part of that was fun. Wait, someone else wrote a different tutorial. Oh, this is on the threads on the forum. A Kurofir. This person. All right. Here's a very simplified explanation of a dynamic memory scheme. See gurus, feel free to correct at will. Real word scheme would be far more sophisticated. I'll use two lists. The first list, the free list, and the allocated list. See, this one's writing like actual like pseudocode at the very least. That's pretty cool. But yeah. All right. I feel even then the splitting thing might work, so maybe that gave me a little bit of like knowledge on what I want. It helped me a little bit figure out what I want, but not really. Not fully. Is there any interesting resources? I don't want to read threads. Because if these people are pedantic and annoying in a wiki, imagine how pedantic and annoying they are on a forum. I'm not ready to manage to deal with that type of stuff. Again, the only reason I wanted to go on the forum is to see if Terry Davis has ever written to it, but it doesn't let me search. Literally just trying to search something rate limits me for a minute, so clearly I've been banned. Okay, physical address, virtual address, segmentation, paging, virtual memory. Nothing important here. Memory allocation, the big picture. No pen and paper, huh? Bold choice. An operating system has many memory management. RAM is allocated in the physical memory manager. I figured as much. Pages are allocated into address space. Typically via... Why are you doing... Unix, I swear to God. And then the available address space is managed to a user space allocator, typically called malloc. This is the topic at hand. Oh, okay. Kernel heap management is very similar, has the same instructions, but uses different functions. At the bottom level, uses the same PMM. Memory is usually mapped into the kernel space by a special function. There's no need for syscalls to raise privilege level. Alright, so this is just about malloc. Useful information, I guess. Somewhat. Not gonna lie, it feels like 9 p.m. It's not even 6, but daylight savings. I feel like it's time for bed at this point. I'm ready to call it a day. No, not really. I mean, I'm gonna keep streaming, but um, yeah, it feels like late at night. It's also like really quiet, so that's not helping. But then again, it was raining earlier, so I'm not expecting a whole lot of people to be out and about right now. And my internet is fluctuating again. Right, situation. Doing some operating system development. Was doing a little bit of like writing unit tests because I knew of some limitations that my allocator had for the system. I don't know about solutions. I was doing a little bit of research on possible solutions, but couldn't really find a whole lot. I mean, I guess it mostly works. Right now, I'm good with that. Okay, I am considering one thing for the alignment, the 4K alignment thing. So again, you allocate a page to then allocate within, but then you allocate more than one page worth of memory or align to a page boundary, and you're allocating new pages which are not being kept track of. In that case, what I can do in palloc, there's usually a header created. Here, mem page. And this header has the free list, a pointer to the next memory, the size of the memory currently being used, attributes, and a pointer to next memory, because memory can be linked together. But on top of that, it could be possible to technically store a auxiliary page array used to point to page allocations done. So when I allocate on a byte on a page boundary, or I allocate more than one page worth of memory, so I'm not doing allocation within a page, but I'm allocating pages themselves, I use another page to keep track of those. So just like store that somewhere and use that to then be like, oh, okay, I used this. When you free this page, you also have to free that allocator. So kind of like that. All right, let me try it. Hold on. First off, this is an 8. Are the allocations at least one page long? You know, bigger than 2 U-longs? Only in certain cases. Like, that's what I'm talking about. For example, here and here, I am allocating actually 8 bytes. I'm allocating uint64. But here I'm doing it on a 4KB boundary, whereas here I'm doing it on a 16-bit boundary. So here it creates a page, here it allocates within this page. So when you free this page, it is going to free this memory. When you free this page, it is not going to free this memory because of the alignment. So that's why I'm saying, when you do this, when you use palloc instead of kalloc, you then keep track of that. So where's kalloc? Here it is. pretty much. Actually, yeah, this case scenario here. When the page is bigger or equal to the page size, you do this, and then it could be something like it should be a not a uint64, but rather a void pointer, or even a type def struct page index, which is going to have a size and okay. Okay, so when you're trying to allocate using palloc, which is when you realize that this is an issue, you're allocating too much memory to put it within a page, so instead you have to put it in its own page. Then you allocate another page, which is then used to keep track of that. And you do hello person whose name I have to admit I don't know how to read. Page alloc size plus plus. Yeah, but this is actually a void double pointer. Yeah, because it's an array of void pointers. Except it's not void pointer. It should keep track of the size as well. All right, there's an ad starting, so let me come back in 3 minutes and actually figure this out. Okay, we're back. And yeah, I was trying to come up with an issue with allocating too much memory and then it not being kept track of. So this will, ooh, my hair was a little bit tangled there. I pulled it. Yeah, the solution that I came up with is simply having a page index that keeps track of these large allocations, besides the initial allocator that keeps track of the rest of allocations that happen within a page. But it's not enough to just keep track of this. Yeah, do we have to type def it? Can't I just do a struct directly in here? Is that a thing that you can do? Kind of ugly. That's how you do that. Okay, that's how you do that. And we also want to keep a page index pointer next with a struct like that. Do we need this information when the block is used? This information is literally just for freeing memory. It's not used in the block itself. But, okay. If there isn't one, we allocate it. Then, what did I say? The page index? Stored in the freed memory. Yeah, this is for page allocations, so you can't really do that. Because the freed memory is unmapped. It's not accessible at all. That is how I'm doing my in-page allocations, but this is for the allocations that are too big to fit inside a page. So, by definition, multiples of pages. Because they're aligned to a page boundary. Okay, yeah, that stays like that. Then, while index next, index equal to index next. Can I not do that? What's wrong with that? Those are literally the same type, bro. Okay, I guess they're not technically the same type. Okay, so we advance until we're at the end, at the tail end. And if index size is bigger or equal to page index limit, which we're going to have to define. Are my neighbors staring down a wall? What the fuck is happening? If the index size is too large, then index next equals to this, a new page being allocated. Oh, and by default, its values are 0, right? Because I gotta make sure that all values are 0. This one is 0, this one is 0, these ones are 0, yes. And then index equal to index next, again with a page index thingy. then we do it here. Index pointers. Index size plus plus as ptr size. But you don't like that because the structure doesn't have a name. Wait, no. That's the easiest way to do it. Size, size. Okay. That may make sense. Not sure. I gotta check. But are you Vim bindings? What? What does that mean? Okay, is it all written? It creates the page, it expands the page if necessary. I want to say yes. Okay, so conflicting declaration. Oh, wait, the reason. Oh my god. That's the reason it was failing. That's the reason why it wanted me to do also page index limit. I left that at 1. That's not right. Because that's gonna use one page as an index every time you allocate a single page. So technically, I guess it works. Technically, it's also not great. But I can get rid of that. I can get rid of that. Now it should work. And it will crash. Alignment fault. Hooey. That's cute. Who? Why? Okay, in the page index limit, I gotta calculate that. Is the page size hold on. Okay. This represents an entire page. Right. How many of these do we fit in? Well, it's based off of, yeah, the page size minus the size of this minus the size of this. And that would be, can I do... minus the size of the page index header. That's not a thing, is it? That's not a thing. I can just move it out here, I guess. The page index header. Now we can use the page index header. And that gives me the total size in bytes of the space that is allocated for the array. And then struct. Can I then address it like this? That's the reason I did it that way. I'm not sure on the syntax of this stuff. And the YouTube delay. Okay. Another structure that I have not defined. Again. Page index entry. That. And the size of a page index entry. There. So that tells us how many entries fit inside a page. Which didn't work. That's the reason you don't see untyped def structs instead of structs. That makes sense. In C++, you can do it. But in C, you can't really do that. So who is crashing? C++ has also auto and stuff. Yeah. Although here I'm using size of, so you don't really get that, but yeah. Let me just use GDB for this one real quick. While I still can, because I won't always be able to. Page allocator on line 209. Well, index header next, index equal index header next. Yeah. And what exactly is the problem with this code? I guess index doesn't exist. Oh, well, yeah, index doesn't exist. Because I need to redo this assignment. The fact that I didn't even write in exit correctly and it still exited. Okay, still an error. Kind of wasn't expecting it. Is it the same place? Damn it, I don't have it copied. Seven to C. Well, no, I changed the code, so it's not gonna be the same address. Isn't changing, so it's while true. No. You check if it has a value and you assign index to it. So next time you check, you're checking on the new page. But let's see how that goes. It didn't print anything. For 2 FFA 000. Okay. And then no, it's a null pointer. Accessed. Line 220. Oh, wait, we've moved all the way here? So I guess it is working now. Well, obviously this is not gonna print. Yeah. And neither is this. Index pointers, and then index header size. Okay, if the value of this is correct, and the value of this is correct, then what the fuck is your problem? Why can I not write 0 to it? Index pointer's value might be 0. It is 0. I mean, where exactly is this pointing? It is a null pointer like that, but and clearly I didn't understand how this is being done. Hold on. I think this is the correct syntax for it. Yeah, that was it. That's the correct syntax for it. Cool. So now that's allocated. And now when we do p3, p3, here it is. Ooh, this is a tough one. Ooh, that's a tough one. Okay. Tiny issue. Pages can be allocated with that header or without that header. Because you can just allocate pages, like full pages. And they won't be given that header that I mentioned. The header that contains the page index, like this header, won't necessarily be there, which means that this won't necessarily be there. Which means that, is this next ever used by the way? Here. Okay, it's done here. This is where that needs to be done. So it won't work in all cases. It'll only work in the heap, but better than nothing, I guess. Free page list with a page index if index header next free page list index header next, and then for int I equals 0, I is smaller than, well, not int. One page allocation gets treated as having the header and the other one is on some free list or something. It's kind of what I'm doing, yeah. I mean, right now it seems like the only pages that can have this are heap pages, so I'm okay with this for now, but we'll have to see. Header size. Then we're going to p3 the index header, no, index pointers object at index I dot pointer size cool. Is this free heap like only exists in here, so it needs to be I don't like this. Instead of free heap, I'm actually going to rename it to free managed page, which is what it's going to be called from now on. And both, well, no, just this will be put in the header of the page allocator. p3 just empties a page. Free managed page is going to be like handling this more complicated allocated page. It's up to you to call the correct one, I guess. This is done by the kernel, so I guess I'll take on the responsibility. malloc doesn't work this way. Well, malloc works this way internally, so yes, but shouldn't be too hard to do properly. Okay, and then instead of calling p3, you called free managed page. Hold on. While I'm on it, might as well do this and this and this and this. No? You like that? Oh, wait, no, hold on. This. Bye, bot eater. Okay, so that is going to be a little bit of an issue, because what this is going to do, it's actually going to crash the system when you try to access it after it's been freed. And yet, that's not what happened. Align memory not fully freed? Well, that's because I'm running the tests in the wrong order. Yeah, crashes the system. But can I remap it? Well, first off, when I free a page, I just unmap it. And then that's it. Okay, so what I gotta check is that assert false. Page used. Mem. No, it still crashes. It is free in it. But then it is still crashing. Okay, it's crashing at this address, alloc test 27. It is actually working. 27? Well, not sure how you can possibly be crashing at line 27 here. Test gate alloc alignment free crashing. Wait. Yeah, okay, it could be that the next one is crashing, actually. I doubt it. No, I don't think that's it. Yeah, no. It's crashing when trying to access the page. Why, though? Oh, because it's trying to read its... probably this is crashing. Yeah. Full page not freed. And also align memory not fully freed. Wait, what? This test shouldn't be happening if this one fails. Don't think that's... Let me check the assert false. Maybe I did it wrong. If the function returns true with the condition, then that is a problem. And you return false. Yeah, I think that's correct. Yeah, if the condition returns true, then this function returns true, and the test returns false. Goes in here, test returns false. Okay. But if this is returning false, then why are we going into this test? That feels weird. Holy typos right there, but whatever. Should not be called. Wait, okay, hold on. No, the way that this is written is wrong. Okay, yeah. It was working, but because the condition was returning false, we weren't going in here. We were printing the error, wrongly printing the error, and then showing the fail error, the fail message, even though it wasn't actually failing. The next one after that was failing because that one was actually failing. Okay, so inexplicably, there's a free for this. Whereas instead, if I were to, if I were to run the same test, but I still call p free here, then I expect the page to have been freed. Okay, so the managed and unmanaged. Okay. Yeah, so when you use pfree, the page is not freed. When you use free managed page, the page is freed. And then there's still the alignment issue, but that one is much smaller because now memory is actually going to be freed properly. Whereas before, there were a lot of page entries that weren't being freed properly. Now they are. Tracking and freeing memory. Large allocations in managed pages. Cool. All right. That was a easy one to fix. Could always say that once you're done with fixing it. It's easy to say that it was easy. It really wasn't. So from this, I would say like, I figured out how to do testing. I kind of unit tested the allocator. Obviously, I have to unit test it a little bit more and then fix the tests that are crashing, but it's going pretty well. Buffer overflow detection is one that is going to wait for virtual addressing to be done. So not something I am super interested in doing right now. Because I need to see how far I can take virtual addressing and what I can use it for to reduce buffer overflows as much as possible. and then use it possibly to detect buffer overflows if needed. Either virtual addressing or some other technique for that. I know there are techniques for detecting that, but I haven't done a lot of research on that. Okay. The system is moving ahead quite a lot. It's November 15th. I started working on the architecture of the system 15 days ago. Well, I started a little bit earlier, I think, like the last week of October, if I'm not mistaken. But since then, I've gotten themes to work. I've gotten inter-process communication, a windowing system, virtual addressing. I'm improving the allocator. I'm starting to write tests. I feel like my camera is lagging a little bit sometimes. Oh, but that's maybe just because I lowered the FPS so that it wouldn't be so hard on my bandwidth. Because yeah, I still don't know what's happening with my computer. I feel like it's my computer. Because yeah, like I ran a speed test on this computer and my other computer, and the other one was like twice as fast. So I'm not sure what's happening with this one. But yeah. I designed a file system. It's not half bad for the 2 weeks that this has been going on, roughly. And I still got a lot of stuff to figure out. But could this be the end of the stream? For today, I believe so. I want to see if I can get virtual addressing fully working. Mostly starting the MMU as soon as possible and doing some research on what I can do with virtual addresses, how I can use them to the best of their, potential, so that I can. Fucking. Why does this always happen when I'm on stream? I sometimes I feel like I need to sneeze, then I don't. It lasts for half an hour. It's really awkward because I'm just making faces the whole time. I'm not really speaking. Happens a lot on stream. But yeah, I need to figure out virtual addresses, but feels like something I don't want to figure out on stream. Just want to take my time with it. But what I do want to do before I end the stream is consider what I'm gonna do tomorrow's stream, because I feel like I'm running out of things to do, which is stupid because I'm not. I have a ton of things to do. I'm just running out of ideas for things to do. Yeah, I feel like I'm mostly running out of ideas for things to do, and for use cases for the things that I need to do right now. If I run this with make run, which I haven't in a long time, so it's not even showing up here. Right, you need to clean. Please work. For the love of God, please work. Okay, yes, thank God. Alright, I'm gonna figure this out. I'm not gonna end the stream until I do. What the fuck? Alright, so... That's so unhelpful. Bro. Oh, it did crash, okay. I thought it was a different thing happening. Okay, when reading a file, what is this size? Is this a really big number or? That's a really big number. Where did this come from? I feel like this is the address and this is garbage. FAT32 262. Okay, so first thing I want to check, does this error happen? Well, we said FAT32. No, let me check the page first. FAT32 CPP on page on line 262. All right, so the error is seemingly on a memcpy. Hmm? Hmm. So this address is not mapped at all. And I'm on the main branch, right? Yes. That's really weird. Because it's happening when I'm allocating a new process. Oh wait. Wait. I may know what's going on. Hold on. Okay, one thing I want to check is if the error still happens if I try to boot from if I try to use the other file system. No, not launcher, shared. If you know how to spell anyway. The error does not happen here. Okay. But it is a weird error, I have to say. Does it have to do with this? Wait. No. Surprisingly, it doesn't have to do with this. But I don't think it was happening here. What? Wait, is it just an error on main that I didn't realize was happening? Or do I need to clean just in case? I'm a little bit surprised. Yeah. It was happening here as well. And then what about here? Bro, how did I not notice this was an error? I'm so confusing. Alright, it doesn't have anything to do with what I wrote today. Instead, it's an error that's been happening on the main branch, and I did not notice was happening on the main branch for the longest time. Because I haven't been working off the main branch. And that has to do with me not writing any code yesterday. So... it's... here it works, but I'm thinking... yeah, here it was using the shared directory. What if I switch it to using the boot directory? I'm so confused by this. It's like, how did I not notice it before? It's been happening for a while. Right, so maybe let's not deal with this. Just, oh, shut the fuck up. And just figure out what the issue is. The error was in the FAT32 driver, which, to be fair, I haven't used that driver in a while because I've been using the 9p driver, so maybe I didn't notice that this was a thing. In the read file, one of these two is not working. All right. Yeah, the address is this one, but is the file just not open? All right. I'm gonna run an ad and I'll be back in 3 minutes, and then I'm gonna figure this out. We're back. Jesus, that's loud. What the hell? Okay. So, there's a crash. Been happening for a while. Didn't even know. But, yeah. Mm, it seems like... I don't know, for whatever reason, I'm opening a file, but then it's not... either not being mapped or not being... I don't know. I don't know what's happening. Okay, so it seems like my file is being opened at 42DDDD which is where I'm reading it. But then, is the cursor just too far? The size of the file is B5. So what is the problem? First off, let me see what file we're talking about. That may give me a clue as to what's happening. Package.info. It's a perfectly valid file. It gets opened. It then gets put into that buffer with that size, and then we try to read inside of it, and then it freaks out. And it says here that it is mapped because it has a value. I don't understand what's happening at all. Here it has a valid entry, so it is mapped. Here it has a valid entry, so it is mapped. It is the exact same entry, so the value exists. Oh, but one thing. Okay. Not sure the syntax on that was correct. It was correct, but in the wrong place. This makes no sense. The entry is valid, but then here it thinks that it isn't. And this has nothing to do with the MMU issues. Because none of the MMU code is in this branch. It's been a while since I've gotten a really weird bug like this one. That doesn't seem to make any sense. I mean, might as well do this, but I doubt that's gonna change anything. L1 table missing. Wait, what? The roadmap to reach this level of coding? Just do it a lot. Hold on. Something really weird is happening here. No, what? How is this address valid, but this one isn't? They're within the same page of memory. And yet, even my debugger seems to think that they're not. Even though the first parts of the addresses are completely ignored. It's meant to be mapped at... Wait, what? There's something corrupting the top part of it. It's becoming 8 instead of 0. And obviously that's not mapped. And only if I add 19 to it. But what if I add it manually? If I add it manually, it works. So that means that the value for the cursor is somehow messed up. This is a weird... That's a weird one. Okay, first off, is 16 enough? I think so, because that's the same number I'm using here. Yeah, there should be 16 to a 64-bit address. Wait, the descriptor cursor is The descriptor cursor is not... the descriptor cursor, I believe, is a positive value. No? No, it is a negative. I mean, an unsigned value. So it looks like its code, its value is what? Genuinely, what the fuck are you talking about? All right, print its integer value. Lines of code is something like 30,000. $25. Okay, starting with the file that the conversion is not even needed. I told you about 30,000 lines of code. 30,919. First off, this is so confusing. Why do you think that this address is mapped to 8? That makes no sense. But what we can do is take the address and do that and see what value that produces. I'm expecting a 0, but it's clearly not going to be a 0, otherwise this wouldn't fail. 8. Where is this 8 coming from? Who put that there? Oh, wait, this is buff. What I meant to do was file. Even though the text is no longer accurate, but I don't care about that. Okay. No, this makes no sense. If file shifted by 37 is 0, and then descriptor cursor shifted by 37 is also, I believe, 0, then how on earth is file plus descriptor cursor shifted by 37 a value of 8? 0, 8. Okay, no, the cursor is wrong. Got it. Language is C. Okay. 080. I mean 088. Why not use cursor AI? Because I want my code to work. Okay. The file descriptor for this. Let me guess. The file descriptor for this is not fucking initialized. Fuck's sake. That sounded a lot louder than I expected it to. The random stack garbage error. The funniest thing is it's random, but it's always the same. Because I would have immediately noticed what the issue was if the value was different every time. It's not there yet for what you do. It's not there yet for anything. Besides the most basic surface level projects. That. Okay. Fuck. It's always the same issue. Alright. Well. Get out of here. Why do I feel like this happens a lot? Actually, you know what? Here's another one. And, not amazing at regular expressions, but this one should do. Why is this even still being done? That's kind of stupid. This one was probably failing in the same way for the same reason. Project. Fixed unallocated memory variables. Okay. Just quickly test. It boots. It opens. Loads that. Looks good. Cool. Well, I should have tested the terminal, actually. You got a whole second setup behind you? Nope. I have a second setup next to me, not behind me. Behind me, it's just a desk. with an old monitor and a Raspberry Pi. So I guess technically, but since it currently doesn't work, not really. But no, not really. Although I do use it sometimes, but I move my computer there. All right. Love that I just wasted 30 minutes figuring out yet another uninitialized file descriptor. It's always the same thing. It's always the same damn bug. But with that, I am ending the stream now. At least it lasted a little bit longer. Somebody said no last time when I was actually going to end the stream, so now I'm actually going to do it. Sorry, but I didn't end it the first time, so you got what you wanted. All right, there is another stream tomorrow. Tomorrow, the same time as today, that's 3 p.m. CET. I will try to remember to restart my router and pray, because I don't know what's happening with my internet, but what's been happening with my internet. It's not necessarily happening anymore. Maybe it's done. So let's think positive that my internet is going to work. Yeah, for tomorrow's stream. Still don't know what I'm going to work on. I guess to a certain extent, it depends on whether I have figured out virtual addressing completely. Which, yeah, we'll see if that's the case. Like I said, I do have some free time today, so I can do that. Maybe if not, I can start like I said, investigating some of this stuff, even if I only want to implement it once I have virtual addressing fully working properly. But virtual addressing is getting there. So actually, one more thing before I go. I'm going to merge this into this. And I'm going to clean. And I'm going to run. I'm going to see if this works. It boots, which is a good sign. It loads one application, which is a good sign. Then it loads another one, which is also a good sign. And it crashes. Translation fault ra, translation fault ra, translation fault ra. Actually, for ra. Yeah, so it's not fully working yet. I'll have to fix it. But yeah, that's kind of what I need to do. All right. So thank you so much, everybody, for joining. I will indeed see you tomorrow. Okay, I did say yes, next stream tomorrow, 3 p.m. So that is it, and thank you so much.